Look at this face. Look at the way the hands are clutched over the mouth. This is not a statue carved by an artist. This is a human being. A mother, a father, a child, frozen in the exact millisecond of their death. For nearly 2,000 years, they have been silent witnesses to the single most terrifying weapon in nature's arsenal. We all know the story of Pompeii. We think we know how they died. We imagine a slow rain of ash, people choking, struggling to breathe, slowly buried in their homes. We imagine a tragedy of suffocation. That is a lie. The people of Pompeii didn't suffocate. They didn't have time to suffocate. They were executed. What if I told you that the force that killed them wasn't a slow drift of dust, but a supersonic wall of fire moving faster than a Formula One race car? This is not a volcano story about lava. Lava is slow. You can walk away from lava. You can take a selfie with lava. Lava is the distraction. The real killer is invisible until it is too late. It is a pyroclastic flow. Imagine a cloud. It looks like smoke, but it weighs millions of tons. It is made of superheated gas, pulverized rock, and microscopic shards of glass burning at 1,000 degrees Celsius. That is hot enough to melt aluminum, hot enough to turn your bones to dust. It tears down the mountain at 450 miles per hour. That is 700 kilometers per hour. It defies gravity, it defies friction, it defies hope. If you are standing at the bottom of the mountain and you see this cloud coming, you are already a ghost. You cannot outrun it. You cannot drive away from it. You cannot hide in your basement. It will flow over your car, through your windows, and into your lungs before you can even scream. Think about the fastest thing you've ever seen. A cheetah, a sports car. Now imagine a mountain falling on you at that speed. Tell us in the comments. If you had 30 seconds to react before a wall of fire hit your house, what would be your very last thought? Who would you call? Or would you just freeze at Y Zone 360? We don't just look at the statues, we look at the physics that created them. We want to deconstruct the why behind the instant fossilization. In this video, we are going to perform a forensic autopsy of a pyroclastic flow. We will dissect the collapse, explaining the terrifying moment when the column of ash hanging in the sky suddenly loses its momentum and crashes back down to Earth, unleashing the monster. We will reveal the physics of speed, explaining the phenomenon of fluidization, why a cloud of heavy rock can flow like water and move like a jet. We will confront the thermal shock, the gruesome biological reality of what happens to the human body when it is hit by 1,000-degree heat. We'll explain the pugilistic attitude of the Pompeii victims and why their muscles contracted into that famous boxer's pose in the instant of death. But here is the part that will truly haunt your nightmares, the part that destroys your last hope of escape. Most people think, I'll just get on a boat, I'll cross the river, I'll be safe on the water. You are wrong. What if this wall of fire could walk on water? In our final chapter, we will look at the Krakatoa eruption, where a pyroclastic flow traveled 40 kilometers across the open ocean to kill people on another island. By the end of this video, you will understand why volcanologists fear this phenomenon more than anything else on Earth. And you will learn why the most beautiful mountains are often the deadliest graves. It's time to face the heat. Welcome to Y Zone 360. Let's deconstruct the pyroclastic flow. To understand the pyroclastic flow, we must first look at the anatomy of an eruption. Most of us picture a volcano as a simple fountain of lava, but the most dangerous eruptions don't flow. They explode. Boom! The mixture of gas and pulverized rock is blasted out of the crater at supersonic speeds. This creates an eruption column, a towering pillar of ash and smoke that can reach 30, 40, even 50 kilometers into the stratosphere. There is a constant war happening inside that column between heat and gravity. As the mixture rises, it begins to cool. It mixes with the cold air of the atmosphere. If it cools too much, or if the eruption loses just a fraction of its upward momentum, the density of the column changes. The mixture of rock and gas becomes heavier than the air around it. This is the tipping point. This is the moment the monster is born. The collapse. Gravity, the patient killer, finally wins. The column can no longer support its own weight. It doesn't just drift away. It falls. Millions of tons of superheated rock and gas suspended miles in the sky suddenly crash back down onto the slopes of the volcano. It hits the ground with the force of a bomb, but instead of stopping, it transforms. The vertical fall becomes a horizontal sprint. The energy of the fall is converted into forward momentum. It behaves like a liquid, but it is made of solids. It hugs the ground, filling every valley, every canyon, every depression, accelerating with every second. It is an avalanche that feeds on its own heat. Think about a snow avalanche. It's scary, but it's just snow. Now imagine that snow is made of glowing hot rocks and poison gas and it's moving 3 times faster. Tell us in the comments. Have you ever seen a landslide or an avalanche in real life? Did the speed surprise you? But there is a second way this monster can be unleashed. A way that is even more unpredictable. The lateral blast. This is what happened at Mount St. Helens in 1980. The pressure inside the volcano didn't shoot up, it shot out. The entire side of the mountain bulged, cracked, and then disintegrated. In this scenario, there is no warning column. There is no time to watch the sky. The pyroclastic flow is generated instantly at ground level, moving at supersonic speeds from the very first second. The forest at Mount St. Helens didn't burn down. It was knocked flat. Huge trees, centuries old, were snapped like matchsticks and laid out in perfect rows pointing away from the blast. The force was so great, it stripped the soil down to the bedrock. But gravity alone cannot explain the speed. A rock rolling down a hill has a speed limit. Friction slows it down. Air resistance holds it back. So why does a pyroclastic flow keep accelerating? How does it move faster than a race car on a flat track? The answer lies in a strange phenomenon called fluidization. The flow isn't just sliding over the ground, it is hovering. It has turned the air itself into a lubricant. In our next chapter, we will deconstruct the physics of speed. We will show you how this cloud cheats the laws of friction to become the fastest thing on land. The mountain has collapsed. Millions of tons of rock and ash are now plummeting toward the valley below. If you drop a boulder down a mountain, it bounces, it crashes, it slows down. Friction is the enemy of speed. The ground steals the rock's momentum until it eventually comes to a halt. But a pyroclastic flow doesn't stop. It accelerates. It can reach speeds of 450 miles per hour, 700 kilometers per hour. Why? How does a cloud of solid rock cheat the laws of friction? The answer is a terrifying phenomenon called fluidization. The flow doesn't just slide over the ground, it hovers. To understand fluidization, we have to look inside the cloud. It is not just dust, it is a highly compressed mixture of 3 things: solid rock fragments, pumice and ash-trapped volcanic gases, and ordinary air that it scoops up as it moves. But remember the temperature this mixture is burning at 1000 degrees Celsius. When air is heated to this extreme, it expands violently. It physically lifts the solid particles apart. It coats every single grain of sand, every pebble, every boulder in a cushion of high-pressure gas. The solid particles are no longer touching each other. They are floating on a microscopic bed of hot air. The friction drops to near zero. Because it behaves like a fluid, the flow is incredibly efficient at navigating terrain. It will pour down valleys, funnel through canyons, and follow riverbeds moving exactly like a flash flood of boiling concrete. So the weapon is incredibly fast, frictionless, and capable of jumping over obstacles. But what actually happens when it catches you? We often see statues and Pompeii bodies frozen in time. We assume they choked on the ash. We assume they suffocated in a dark cloud. This is a historical misconception. Suffocation takes minutes. A pyroclastic flow kills in milliseconds. In our next chapter, we will open the medical files. We will deconstruct the brutal biological reality of thermal shock. We will explain exactly what happened to the victims of Vesuvius and why their bodies locked into that famous agonizing posture known as the pugilistic attitude. Recent forensic analysis of the victims' bones has rewritten the history of that fateful day. They didn't have time to suffocate, they were killed by something far faster and far more violent: extreme thermal shock. To understand the sheer brutality of this death, we have to look at the numbers. The temperature of the pyroclastic surge that hit Herculaneum is estimated to have been around 500 degrees Celsius. When a cloud of gas and pulverized rock at 500 degrees Celsius envelopes a human body, biology simply stops working. It happens so fast that it overrides the body's ability to even register pain. And this intense heat explains the most iconic, haunting image of Pompeii, the twisted, curled up bodies. For a long time, people assumed these people died cowering in fear trying to protect themselves, but medical science tells a different story. When the human body is exposed to extreme heat, the proteins in the muscles instantly dehydrate and contract. The stronger muscles overpower the weaker ones. Your arms pull in towards your chest, your legs pull up, your toes point downward. This is an involuntary post-mortem reflex known as the pugilistic attitude because the victim ends up looking like a boxer with their fists raised to protect their face. They weren't cowering in fear. Their bodies were simply reacting to the physics of extreme heat snapping into this position at the exact moment of death. The ash that fell afterward didn't kill them, it merely buried them. The fine ash settled over their bodies, creating a perfect airtight mold. As the bodies decayed over centuries, the molds remained. When archaeologists poured plaster into those empty spaces, centuries later, they perfectly captured the exact millisecond those muscles contracted. They are not statues of people dying, they are 3D photographs of thermal shock. What if you are miles away? What if there is a massive river, a bay, or even an ocean between you and the volcano? You would think water, the opposite of fire, would stop it. You would think you were safe, you would be tragically mistaken. In our next chapter, we will expose the most terrifying trick up the volcano's sleeve. We will look at the 1883 eruption of Krakatoa and prove why a cloud of fire can walk on water. The heat isn't just fast, it is unstoppable. What if? I told you that a pyroclastic flow, a massive 1,000-degree cloud of rock and gas, does not sink when it hits the ocean. What if it can actually use the water to travel further faster and with deadlier efficiency? To understand this terrifying violation of common sense, we must look at the cataclysmic eruption of Krakatoa in 1883. Krakatoa was a volcanic island in Indonesia. When it detonated, the explosion was so loud it ruptured the eardrums of sailors 40 miles away and circled the globe 4 times. They were wrong. A massive pyroclastic flow triggered by the collapse of the eruption column raced down the slopes of Krakatoa and hit the sea. But it didn't stop. It crossed 40 kilometers of open ocean and struck the shores of Sumatra, instantly incinerating thousands of people. Have you ever dropped water onto a pan that is incredibly hot? The water doesn't just sit there and boil away slowly. It instantly vaporizes the bottom layer of the water droplet, creating a tiny cushion of steam. The droplet then skitters and glides across the hot pan, insulated from the heat by its own vapor. A pyroclastic flow over the ocean is the Leidenfrost effect on a planetary scale. The ocean does not absorb the heat because the steam acts as a perfect insulator. The flow retains its terrifying speed and its lethal temperature, gliding across the ocean surface as easily as it glided down the mountain. The journey across the Sunda Strait took the Krakatoa flow only a few minutes. To the people on Sumatra, the sky would have darkened, the air would have suddenly turned to an oven, and the wall of superheated glass and rock would have enveloped them before they could even understand that the ocean had failed them. It proves that there is no geographical barrier, no natural shield that can stop it once it has been unleashed. It is a force of pure kinetic and thermal momentum. We have deconstructed its birth, its frictionless speed, its brutal biological impact, and its terrifying ability to cross oceans. We have stared into the heart of the 1,000-degree monster. So knowing that you cannot outrun it, that your house cannot withstand it, and that not even the ocean can stop it, what is the final lesson? How do you survive? The unsurvivable. We will give you the only honest survival blueprint for a pyroclastic flow. We will discuss the zone of death and why understanding the why is the only thing that will keep you out of the ash. If you can see it, you are already dead. There is no bunker deep enough, there is no vehicle fast enough, there is no suit strong enough to withstand a 1,000-degree cloud of pulverized glass moving at 450 miles per hour. The survival rate for a direct hit is 0. Phase 2. Listen to the earth, not your eyes. You must learn to listen to the instruments, not your eyes. Are there swarms of micro-earthquakes happening under the mountain? Is the ground physically bulging or inflating, indicating magma is rising? Are the gas emissions changing? These are the whispers of the monster waking up, and these are the signals that scientists at observatories around the world monitor 24/7. Your survival depends on trusting their data over your own sense of security. Are we making the same mistake as Pompeii at Y Zone? 360, we deconstruct these immense forces of nature because awareness is the only true shield we have. We cannot stop the magma. We cannot slow down the cloud, but we can understand why it happens and how it moves. Knowledge doesn't defeat the volcano. It defeats the ignorance that keeps us in its path.